Good morning. Today we are going to discuss context sensitive grammars. Context sensitive grammar is in the Chomskyan hierarchy. Type 0 is grammar is called unrestricted grammar, and type 1 grammar is context sensitive grammar. Type 2 grammar is context free, and type 3 is regular grammar. So this is the gradation. That means regular grammar, context free grammar, context sensitive grammar, and unrestricted grammar. And regular grammar accepts regular languages, context free grammar accepts context free languages, context sensitive grammar accepts context sensitive languages, and unrestricted grammar is accepting recursively enumerable languages. And the automata tool which is accepting regular language is finite automaton, whether it is deterministic, not deterministic, with epsilon transition, without epsilon transition, etc. etc. And context free grammar is accepted by a PDA which is deterministic PDA. And if non-deterministic PDA, that means PDA by default is not deterministic. If a grammar is accepted by or a language is accepted by a deterministic PDA, that language is called deterministic context free language. And CSL context sensitive grammar is accepted by a tool known as linear bounded automaton, and unrestricted grammar is accepted by a Turing machine. Okay, then what is type 1 grammar? Type 0 grammar is alpha derives beta. That means here alpha derives beta, there is no restriction. Unrestricted grammar, that means left hand side is can be variables or terminals, or it's a combination of variables and terminals. Right hand side also is a union of or it's a combination of variables and terminals. That is alpha derives beta. That means left hand side derives right hand side. Left hand side is having a set of terminals and non-terminals, or terminals, non-terminals, or set of terminals and non-terminals. Right hand side is also there is no restriction. But if you are imposing a restriction, that means length of the left hand side is less than or equal to length of the right hand side. That means modulus of alpha less than or equal to modulus of beta. Left, that means right hand side is at least as large as this one. That means the right hand side is at least as large as the left hand side. That is length of alpha less than or equal to length of beta. That means it's a length increasing grammar. And the automaton or tool which is accepting context sensitive grammar is linear bound automaton, that we will discuss later. Now here this is an example grammar. S derives ABC or AABC. This is context free grammar. That means left hand side is having a single variable, but here you have a variable as well as a terminal, and right hand side is also a terminal followed by a variable. Here you are having two non-terminals. Here a non-terminal plus three terminals, and likewise like that. Suppose that, or I am going to derive a string from this. S derives A, B, C. Now I am going to replace this AB. That means AB with BA. Okay. That is derives AB derives BA. That means BAC. Now see, this is having AC. AC I am going to replace that AC with AB. I am going to replace this AC with BCC. BCC. Okay. Now here I am having this BB. Here also we are having BB. So I am going to replace that with BB. This BB is replaced with BB. That means BB, BCC. Now AB derives A. AB derives A. Now I am going to replace that with A, B, C, C. So this is a string. That means two A's followed by two B's followed by two C's. That means this is A to the power 2, B to the power 2 and C to the power 2. And say this is the grammar. This is the grammar which is accepting A power n, B power n, C power n. A power n, B power n, C power n where n greater than or equal to 0. This is A power n, B power n, C power n where n greater than or equal to 0. That means this is the grammar which is accepting this set of languages. So regarding this context sensitive grammar in the Chomsky hierarchy, this is unrestricted grammar, this is context sensitive, this is context free, and this is regular. This is regular, this is context free grammar, this is context sensitive grammar, and this is unrestricted grammar. And these are the tools which are used for that. So, as we have already discussed, this A power n, B power n, C power n. In our pumping lemma, using pumping lemma, we have proved that A power n, B power n, C power n is not context free. That means you cannot have a context free language for accepting this. So, we went after, or we are going behind this context sensitive grammar for a solution, and the solution is this grammar is accepting A power n, B power n, C power n. Now we are going to discuss linear bounded automata. Linear bound automata is actually it's a tool for recognizing or tool for accepting context sensitive languages. In the Chomsky hierarchy, we have a regular language is on the core, and you have DCFL or deterministic context free language, then CFL, then that means here regular language there are two types of context free languages: deterministic context free language and context free language. Then on the outer you have linear bound automaton, that means CSL, and after that this is unrestricted grammar, or this is a recursively enumerable language. Okay, that means regular language is accepted by a finite automaton, DCFL is accepted by a DPDA, context free language is accepted by a PDA, CSL is accepted by an LBA or linear bounded automaton, and recursively enumerable language is accepted by a Turing machine. And see, your LBA is less powerful compared to Turing machine and it's more powerful compared to PDA. That means in power, PDA less than linear bound automaton less than Turing machine. The most powerful one is the Turing machine, and linear bound automaton is less powerful compared to Turing machine, and push down automaton. This is push down automaton is less powerful compared to this LBA and Turing machine. Now we are going to discuss what is a linear bound automaton. A linear bound automaton is actually it's a non-deterministic Turing machine. Non-deterministic Turing machine, and suppose that you have a Turing machine, non-deterministic Turing machine. We are having Suppose that you have a Turing machine, and suppose that your input is printed here, and here you have blank, 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 etc. to the left, and blank, 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 etc. to the right. That means in between you are going to print or here you have the input, and To the left and to the right you have a set of blank symbols. That means your tab is infinite to the left as well as to the right. It is infinite to the left as well as to the right. That is, you are having blanks. Here also you are having blank. Okay. Now in between you have the input printed here. Input is printed here, and we are going to process that input. But unlike this Turing machine, linear board automaton is having your input fixed on both sides. That means if you have the input here, the left end is fixed by this and right end is fixed by another dollar. That means here this is the left hand marker and this is the right hand marker, and in between, that means the finite control can't go beyond this, and it cannot move after this dollar. That means its movement is limited by this symbol and dollar. Okay, that is a linear bound automaton, and it's a non-deterministic Turing machine with a bounded tape. Bounded tape means the left hand and right hand. That means its movement is restricted by this symbol and this symbol. That means it can move only up to that point, up to this dollar, and to the left you can is bounded by this. That means it's a bounded tape, and LR bounded means it is left and right. That means it is linear bounded. Linear bounded. Okay. Now it's having 9 tuple. It's a 9 tuple. Q, as you know, it is a set of states. Sigma is the input alphabet. Tau is a set of tape alphabet. Delta is a transition function. That means that transition function is defined as q cross tau. That means upon reading a type symbol, it can have any one of this. That means it's a non-deterministic Turing machine. That is why you have 2 raised to something. If it is a deterministic one, we don't have any this q cross tau cross left or right. That means after moving to a new state, it's moving either left or right, and after printing this symbol, on the tape. Okay, that means this is just like a non-deterministic Turing machine, and delta is transformer, q0 is the start state, b is the blank symbol. These two are the left and right hand markers, and f is the set of final states. And LBA can accept epsilon. LBA, the main difference between LBA and CSL is LBA can accept epsilon, whereas CSL cannot. CSD never generates epsilon. That means one and only condition for that means length of alpha less than or equal to length of beta. That means A derives alpha. A derives epsilon means here length is 1 and here length is 0. Then 1 less than or equal to 0 is not it is not satisfying the condition. So the right hand side never be epsilon, can never be epsilon. So that is the difference between LBA and CSD. That means LBA can accept. That means in between this left hand marker and right hand marker, suppose that there is no content, that can be accepted. Okay, that is why you can have LBA can accept epsilon, whereas CSD, as per the rules of CSD, that means length of alpha less than or equal to length of beta. As per this, it can't accept epsilon. So that is the difference between LB and CSD. If LB and CSD are equivalent if L is epsilon free. That means if null string cannot be accepted, if you are excluding null string from your language, then LBA and CSD are same. And difference between Turing machine and LBA is here left hand and right hand are fixed for LBA, whereas in Turing machine there is in the type is infinite to the left as well as to the right. Okay, and that's all about linear bound automaton. And linear bound automaton is a 9 tuple q sigma tau delta q0 b. These are the two left hand and right hand markers, and f is a set of final states. It is nothing but a non-deterministic Turing machine with a bounded tape and LR bounded. That means left side and right side is bounded, and it is having a 9 tuple, and these are all about linear bound automata, and design of design of linear bound automata is not required as far as your syllabus is concerned. So with that, I am concluding the session, and that's all about linear bounded automata. Okay, thank you.